started taking a look at some different visual representations for data. And the one that we ended on was a bar graph. A bar graph we described to be very much like a histogram, which also has bars in it. The difference primarily between a histogram and a bar graph is that histogram has sort of interval data. And so what happens is the bars end up touching each other and they're annoying. And we had a picture that looks like this. So we looked at interval data of, say, for instance, grades. And then we created a bar chart, and the bar chart has more of a categorical data field. So grades is maybe not the best example, but if you were talking about something about race or about gender or something like that, bar charts are often used, bar graphs are often used because those are categories that you're grouping people in instead of intervals of something. Heights, weights, things like that, that's interval data. Okay. So we're going to take one more step with a bar graph and talk about a double bar graph. And double bar graphs can be used to compare data, kind of like the frequency table that we did last time as well. We did a group frequency table, and then we did a back-to-back stem and leaf plot that looked like this one right here, I believe. And so we were able to look at that and make some very clear assumptions and descriptions about how the data is similar and how it's different based on seeing all of it in comparison at one time. So we're going to do the same thing with a bar chart now, or bar graph now, and we're going to be able to use that to compare the data. So example 8, it says using a back-to-back stem and leaf plot, I should say, using the back-to-back stem and leaf plot, the one I just actually showed on the screen. From example 4, create a double bar graph for the data. So the stem and leaf plot that we're going to be using was over here. And we're going to be grouping the data into categories, okay? And the categories, since this is, grades, are very nicely the different letter grade categories, and that's what we're going to be grouping them into. So if you look at this over here, so flip back for yourself. Can't have both of them on my screen at the same time. That's a feature smart version of that, right? I should really show two screens right beside each other that aren't next to each other. That would be really nice. Maybe it doesn't know how to do it. Maybe. And so we're going to do that with this data. So in taking a look back at that data, let's actually just make a list so that I have it on this screen of the information. So we had exam 1, and what I'd like for us to do, hang on a sec. Have I done this in this class before? Okay. I did it the first time I did last earlier this week. It was yesterday, maybe last week. Did I do the last video? Yeah. Excellent. All right, from the exam 1 that we had from before, we had letter grades of. All right, let's start again. There we go. A, B, C, D, F. And then let's compare that with exam 2's data of A, B, C, D, and F. So looking at them, I want to just write down what we have. So from the stem and leaf plot, or from the tally, or from whatever information from exam 1, it looks like I had 4 A's. Is that what my numbers? 4. Yeah. And 94, 90, 94, and 90, so there's 4 A's for exam 1. I had 6 B's. There were 4 C's. Oh, it's a negative 4, it's not. I didn't have any in the 60s range. There were no D's, but then there were 4 F's. And then in exam 2, I had 11 A's, 4 B's, 2 C's, 1 D, and 0 F's. So this is just writing this information down. What we're going to do is we're going to create a bar chart for this. So I need an axis, and anytime I have an axis, I need to label it, so that'll be my next step. I need my axes on the vertical to be the frequency, as in how many of them I'm going to have. And on the horizontal, I'm going to do the letter grades. So I don't need the sort of the zigzag right here because I'm not doing interval data. Okay, I'm going to do letter grades. And on my vertical, I've got to go all the way up to at least an 11 because this data went up to an 11. And then on the horizontal, I need my letter grades of A. But we have to be careful because what I actually need is I need an A for both tests. So this is A for test 1, A for test 2. And I think I'm going to run out of space for making that big, so let me make mine just a tad smaller. So here's A. And then I'm going to have letter grades for B. Okay. And then I'm going to have letter grades for C. The letter grade of D, and then the letter grade of an F. You notice I got all kinds of little bitty marks everywhere. Alright, exam 1 I'm going to list first, and exam 2 I'm going to list second. Okay, so the first bar I'm going to do is going to be for exam 1. So exam 1 had 4 A's. I'm going to take my number, my size of my chart, and make it 4. So this one's 4. And then exam 2's A count was 11. So I need to make this bar 11 high. So the numerical order of exam 1 and exam 2, we just need to make sure we do all of them in that order now. On exam 1, there were 6 B's. I need to go back and mark the frequency numbers. Let me do that real quick so you can more easily see this, and this should be marked, but I just didn't do it. If you don't want to mark every single one of them, that's okay. Just mark every couple of lines of it or whatever to give yourself some scale perspective. So if you wanted to just mark all the evens or something, that would be fine. Second test, B count was 4. Oops, I forgot. I need my rectangle. First test C's, there were 4. That's my most popular number on this display. Second test C count was 2. More time. There we go. So first test D's was 0, but second test D's was 1. It's a very small one. First test F was 4. I told you 4 is my most popular number. And the second test had 0 F's. Now, I showed you I can color these and they can look really pretty and stuff in a smart note, but in particular, you need to color this diagram to differentiate which one was exam 2 versus exam 1. So you can pick either different colors or you can pick shading going in different ways, which is what I'm going to model on this one. So this one's exam 1. So all of my exam 1s are going to get shaded the same way. And I need a key that says that when I have shading like this is exam 1. And then I need to decide how else to do the shading. Maybe you do cross hatching, or maybe you do your crisscrossing the other direction. That's what I'm going to do. Maybe you do it horizontal or vertical. Okay, it doesn't matter. Just pick something different. And all of exam 2 gets colored that direction. And yet again, we have another visual representation for comparing this to this data. Okay? Alright, the one last one, that the first time we've done something that doesn't involve charts, or at least not a bar chart, is this is a circle graph, or a pie chart, you may have called. This consists of circular regions partitioned into disjoint segments of a pizza. So pizza or cake or something where it's cut to pieces. This graph actually shows how the parts are related to the whole. You see, what the other graphs did is that we didn't actually compare, per se, the number of A's compared to everybody who took the test. We compared the number of the A's to the number of B's to the number of C's, and you can see the bars at different heights doing that, right? And we can tell that information by what I'm about to show, but the pie charts actually do really nice at being able to see, oh, it's a fourth of the class because I have a fourth of the pie. Or, oh, so half of the class got this grade, or is this tall, or has this political persuasion, or whatever it is you're measuring. You can see it as compared to everybody as a whole, instead of just seeing it compared to each of the individual other any of these that you're testing it against. All right, so it says use the group frequency table, we'll go back to it in a second, to construct a circle graph for the letter grade disbursement from exam 2. All right, so from exam 2, we have this one. This is my frequency table. This simply told me how many A's, B's, C's, and F's we had on ABCs and D's. There weren't any F's that we had on exam 2. And I'm going to write those in here again, just like I did on the last page. So this was exam 2. We had, how many A's? Was 11? Save yourselves some space because we've got the math to work out. There were 4 B's. There were 2 C's. And there was 1 F, or no, there was 1 D, rather. Okay, did I get those written in right? Yeah, from exam 2. Sorry, I think I had a typo on my paper that I wrote down. Okay, that's fine. How many grades were there total? That's the next thing. 18, right? There are 18 grades total. So what I would like to know is I would like to know what the percent is each of these is out of 18. Okay? And what I'd like for us to do is to go ahead and divide these. Okay? And we work with percents in this class, so when we divide these, we make it a decimal. How do you turn a decimal into a percent? You multiply by 100 or you move the decimal to the right, either way, right? So let's take that. So if I have 11 over 18, what percent is that? We'll go with whole number percent for now. What percent? Do we have a calculator for today? You should. It's math, right? I have 61%. I'm going to write down the decimal first, 0.61. And then I'm going to write 61%. And we're going to do one more thing with it in a moment, so keep your paper from getting too far off base to write too large. All right, we have 4 out of 18. That's a 2-2, or 22%. I have a 2 out of 18. It's an awful lot like a 0.11 or an 11%. And then I have a 1 out of 18. Which is 0.06 or 6% when you round anyway. So if you think about a pie or a circle, what we want to do is we want to somehow take my circle and I want to divide it into pieces that are this big. One of the pieces is 61% of the pie, one of the pieces is 22% of the pie, and so forth. Okay? Here's something from geometry. Let's see if you remember. How many degrees are in a circle? 360. Okay, so what we're going to do next is we're going to take each of these, and we're really going to do it with the decimal, but we're going to take each of the decimals and we're going to multiply by 360. That's going to tell us how to create the angle in our circle to make it actually be 61% or 22%. So what I'm going to do is I'm going to take 0.61 times 360 degrees. I'm going to take 0.22 times 360 degrees. 0.11 times 360 degrees. And 0.06 times 360 degrees. These will be the most accurate if you actually do them without the rounding. Like if I use 0.6111111, that's what this really was, I'll have the most accurate possibility. But when I get my degrees, just use a whole number of degrees. Okay, we're not looking for something that's going to be super duper precise because we're looking for a visual image that describes what we're doing anyway, and a visual image isn't exactly precise. So if I do 11 over 18 or 0.61 and I multiply by 360, I actually get 220 degrees here. And if I do 0.22 times 360, I have 79.2. Like I said, we're just going to go with whole numbers. This is about 79 degrees. Probably is exact if I used 4 out of 18. Let's see here. It's actually exactly 80 if I use the first number. Use the fractions. So go with 80. If you put 79, I'm not going to I'm not going to be mad at you, okay? It's okay. 80%, 80 degrees rather. If I take 2 out of 18 and times 360, I have 40 degrees. And if I take the bottom one, 1 out of 18, I have 20 degrees. Everybody okay so far? All right, so I'm going to show you some interesting things. We'll see if I can find them again on this. I haven't found them in 6 months, or I haven't looked for them. We need a circle, and my circle on this, because of the way that it distorts, it's not going to look like a circle, so just bear with me on that. Yours will look like a circle because you have the ability to make it look right. But this one looks rather like an oval, doesn't it? So there's my circle, okay? And I want to take this circle and I want to make it so that I have pieces of pi that are 220 degrees, 80 degrees, 40 degrees, and 20 degrees. And let's see if I can find it. Write it down. Of course. Okay, so if you don't have a protractor, it's not a big deal. I've got extras in my office and I'll bring them next time. I need to make my protractor so that it's in the middle of this circle to start with. That looks pretty good. It's not too bad, yeah. So the thing I need to do first is I need to locate what I call the center of my circle. Whoa. Forgot that I can't do it that way.
I think you can lock that image.
Can I? That's a good idea.
If you do click on it, I think, in that lockdown bar. Locking. Lock it, please.
Awesome. Thank you. All right. I want to put a point right here. Is it going to let me write on top of it?
It should.
I would have thought it would too. All right, let me try this. Maybe I line in the middle in first. All right. You can't see it too well from where you are, but on the protractor it marks in 20 or in 10 degree increments. Okay. I'm going to start with the smaller ones just because they're easier to work with. The first one I have that's small is just 20 degree increments. So if I go out 10, 20, it's right here. We'll fix these in a minute. If I go from here and I go 40 degrees from here, I can count by 10. So I got 10, 20, 30, 40. Here's my 40 degree one. And if I go 80 from here, I can go 10. Did I get that right? Yeah, I did. 10, 20, 30, 40, 50, 60, 70, 80, and I'm right here. Okay. So let's move this on now. If I take my line and I start from the middle and I go out to where these are, this will work things out. This is what you would do with a regular protractor. Anyway. And then your pieces of your pie are the different split pieces. The smallest piece right here would be the D's because it was the 20 degrees. Inside of this piece or on the outside marking beside it somehow, you need to mark both the degree measure, 20 degrees, and the percentage, 6%. Okay? That way if you're not exactly at whatever, I know you were trying to get to 6%, okay, or whatever. This one was my C range. This one is 40 degrees and 11%. This is my B range. I had 80 degrees and 22%. This is my A range. I had 220 degrees, which is exactly what's left here, okay? And then 61%. And so I can very easily look at this and say, oh, I don't have to do any numbers because I've got the numbers already on there. But I can see a visual picture of what 60% of the class would look like if it were represented in a pie chart. The majority of the students got A's. But you know there's a lot of students who got B's too, and the D count's really small. that kind of stuff as a visual picture for it. Any questions?